That's infinity. So, did you know, Spencer, that there are different kinds of infinity?
Yeah.
There's not just one infinity. We have conventionally, starting from 0, 1, 2, 3, 4, 5, and so on, and so on, so on, so on. But, so that's infinity, right? Goes on forever. They'll never end. But I'm saying in between any two numbers, there's an infinite amount of numbers. So, let's say I do this. This is my 0. This is my 1. So I'm really just dealing with this part right here. So I could go what? 1/100. 1. No, I can't do that. Has to go 99, right?
Sure.
99,
I could just do
99, and I mean, I could start this even with infinite amount of zeros just right here. Right?
Right.
0, 0, 0, 0, 0. So, anyways, so in between, and even between this 0 and this 1, let's say 100 billion, no, 100 millionth here, there's an infinite amount of numbers in here. And then I can break it down even more. So, the question is 1% of infinity, did I do that backwards? Of infinity, 1% of infinity, does that equal infinity? Because we don't know what the end number is. So I have to say that, but I'm going to say this infinity is less than the bigger infinity.
Yeah.
And so, now you're going to hate this. Infinity is infinitely small,
It's not.
infinitely
Well,
large, and infinitely in between.
It isn't in between.
Yes.
I can say it's infinitely small because you can have a negative infinity. That's a possibility. I can say it's infinitely large because you can have a positive infinity. But in between a negative infinity and a positive infinity is 0.
But between any two numbers. Any two numbers.
Okay, but you're saying infinitely in between two infinities is 0. If it's infinitely small and infinitely large, the middle of that timeline or that graph is 0.
0 is clearly not infinity.
Yeah.
There's, if there's nothing, then of course there's no infinity in that. But here we could do that, and then we could even break it down even more. We could go to 0.5%.
Yeah.
And then to 0.25%. People just naturally just go, no, infinity goes on forever and ever, and it's one number. It's not. There's so many infinities in there.
Right.
So anyways, that's your mind blowing.
You can actually, here, if you want to take the camera, I'll show them how you can prove this. This is real simple. You can actually prove that there are infinities greater than other infinities. This is real simple. So if you actually take this, I remember I saw this on Vsauce, so credit goes to Michael from Vsauce 1. Actually, he's a famous mathematician. But he gave me this idea, so I'm not claiming any credit for being a smart person who came up with this. This is just something I saw.
What? Are you saying you're not smart?
I'm not. I just know a lot of junk. I read a lot of books.
Oh, so you're cheating.
I wasn't popular in
So you mean you cheat? You look up stuff?
Yeah.
Whoa.
Alright, so we go 0.
You're going to have to write big.
5. 0.1568966 ... 1.22.
Oh, is that British guy?
8. No, this is just some. Well, I saw this from Michael from Vsauce. So 6 2.3987436 6, 6, dot, dot, dot. I don't keep track. We'll do one more. 9, 9, 8, 7, 5, 3, 6, 6, dot, dot, dot. Okay, so we'll do, this represents an infinity. So this is an infinite number of 0 through infinity.
Right.
And this is an infinite decimal after it. Now, if you actually run through the full chart, you spent an infinite amount of time writing this full chart out, you'll find that you'll have used up all of the whole numbers. But let's say I do this. I switch these two numbers. And then I switch these two numbers. And maybe I switch these two numbers. Now, despite the fact that I have used up all the whole numbers, I'm still able to create new decimals, and therefore the amount of the total amount of numbers versus the total amount of whole numbers is actually greater. So the total amount of decimals and whole numbers is greater than just the total amount of whole numbers. So the total amount of numbers altogether is greater than the total amount of whole numbers.
Wow. So that's a greater infinity.
Yes, it is a greater infinity. This is definitive proof that there are infinities greater than other infinities.
Whoa. Did your mind just blow up?
Try it at home. Send the results. Yeah.
Yeah.
Alright.